Okay, so I'm starting to build using Andrew Newton's excellent instructional videos on YouTube for building tape and Depron wings using 6mm Depron. Basically taping it on one side and then bending it over, causing a crease, bending it over, and in this instance using a 6mm rod for a wing spar, and then it's going to be still about to be glued over then to form a full wing. What I've done so far is I've built 3 wings. So in Finland, where I'm based, these are 80 centimeters wide, so it's going to be 3 times 80 or 2.4 meters a wingspan. The outer wing tips are going to use the 6mm wing spars, and the one in the middle I found is it 8mm square carbon fiber tube, and the hole in the middle is 6.5, so that means that a 6mm carbon fiber rod will slide just in. For the nacelles, where the tilt mechanism is going to go on the front servos, I just cut 2 3mm birch plywood sheets, 11 centimeters by 15 centimeters, and the stiff side is on the longer one. When you try to bend plywood, it bends more easily in one direction than the other when we're talking about these thin plywoods. Now, what tilt servo do I use? I just happen to run across something called Make Block Servo Robot Pack Blue. It says here makeblock.cc. Bought it from Germany. This is product 80061. Easy to mount the motor directly onto this bracket, and that's what I'm going to do. It pivots on just a friction bearing on this side, and the other side is attached to the servo shaft. What I've done is I've done some 10 centimeter by 3 centimeter from 1.5mm plywood. I'm gonna epoxy them vertically to each side of the servo. The servo is 20mm thick, and I put 30mm up here. I'm gonna cover it later with Depron covering. The idea is to be an air inlet and place the ESC controller afterwards into them. They come with a couple of aluminum brackets. These are, by the way, very heavy. I think the servo in itself weighs almost 80 grams, and with everything this is in excess of 100 grams for one tilt mechanism, which is double compared to what it needs to be. But removing the servo, one thing you need to do is it comes with the servo connector. It's not a Futaba or JR style, what we are used to in the RC world. When you put them with the bracket on and everything, I think I end up at 92 grams, which I'll also make sure that when I do the tilt, that I have the servos mounted in the same way. So if I don't want to use separate channels and invert them, I can have them on the same tilt channel and they move in the same manner. So I'll be paying some attention to the fact that they should be able to move off the same servo control, even if they will be driven in my application from the 2 separate BECs. Now let's see. I finished off yesterday evening by using some epoxy then to glue on the flanks and stabilizing them with tape. The purpose being that I would be able then to put in the tilt servos here in between them. I used some triangular balsa wood just as to stiffen the whole thing up. Okay, so after drilling out some attachment holes and filing in a groove for the servo wheel. A Dremel is really handy. Servo testing. Okay, so both are connected to a Y harness now. Okay, a test like this will show you the fact, for instance, that this ear is now snagging onto the bottom plate. So that definitely. Okay, after rounding off the corners, I need to tidy it up still, and cutting off the ears of this one, making room for it on the other side. What we have is this is one extreme position. There's no growling from the servos, and they go all the way back as intended. So it's just a matter of finding out the position. Now that we got that, it's time to start thinking about how to attach the center wing with the nacelle. Cutting out a little groove for one of the screws. What I'm doing is I'm placing the wing is supposed to rest here on top of the plywood, and since I did the plywood 15 centimeters, which is the chord of this wing, I then just used the rear edge as alignment. I put it there. I then put the spar against, drew with a pencil, 8mm drill, a round hole in the middle, and then just used a sharp knife to make the whole square. So if I now go, and it's just, you can see, the wing spar is supposed here now to lock this into place, and I will now drill a hole. Mind you, there will be five signal wires and one ground coming from the middle one here. There will be aileron, flap, ESC, tilt, and then if I choose to take the elevons for the back and route it through the nacelle, that will be the fifth wire coming in. So I'll use the BAC to power the wing servos and the tilt mechanism, and also the elevons, and just having ground running into the center fuselage, no plus 5 volts, because that will be then fed locally, and the same one for the other half of the wing, because the stall current for this servo is 2.5 amps, and this is a 4 amp BEC. Okay, so that's true. Okay, after a little bit of fiddling, the wing is now holding nicely together. I've decided to have the tail booms half a meter apart, 50 centimeters, probably too little. I go for 3mm, and about 90mm of plywood in the stiff direction again. Cut it off, cut it in half on the table saw, and then just embed it onto the bottom of the wing and have the tail boom rest on top of that. score the tape, and now I'll be peeling it off in order to use it then for gluing. Installed a 6-pole ribbon cable. I happened to find that from a grab bag. I'm gonna take the wing connections using 2 multiplex connectors just on the underside to connect the signal wiring through these 6 wires out to the wing. That was not strong enough. Learn number 1 is to maybe not put the glue on the carbon fiber rod first, because it conducts heat so well that it cools very quickly. So I was able to peel the whole thing on top of the carbon boom off. Whether on the other hand what's been glued on the Depron, that's all good and sound. So what I'll do is I'll put down a bead of glue here inside on the Depron and try again. I put some zip tie around the ribbon cable and pushed it in. Put it down and then stick it down. When it comes to torsion, how much you can twist the wing, it's not crazy stiff or anything. I think it's might be even borderline. It's a little bit cramped at the moment. I have an AVG 14 cables coming through the wing for an EC3 connection over to the ESC that I placed on some Hookah loop tape. The coils to the motor go just simply go forward and will be going under the bracket of the tilt of the servo. I have an extension cord to go to the aileron servos for the wing. That's gonna continue. I have one cable going in underneath to the flap servo, which is just here preliminarily installed, not glued on yet. Using I think these are 10-gram Metal Gear servos, just cheap ones from Hobby King. I used a little piece of PCB and some pin headers soldered on to make a connection for the plus and the minus of the power. So the BEC from the ESC is supplying power to one nacelle. It is this is a four part. I just had a 4-part split. I have a 6-part ribbon cable going through, as you remember. The 4-part split has then motor and the BSC supplying the power. It is the tilt for tilt servo, then it's the flap servo, and then it's the aileron servo going out, and 2 spares. It looks a little bit untidy because I have a test setup hooked up to it. I have a connection for the power. So this is just a built-in Y connection going through the wing to both nacelles. I then have the ribbon cables coming out two separate. Each of them are just the signal wires are soldered on at the moment. The rear motor will also have a BEC, and that will be supplying power to the RX, but because I haven't hooked that up now, I have a separate BEC at the moment supplying the RX with power. The point being is that the common ground is going to be transmitted through the power cable. It's quite important not to build a ground loop, because if I've had ground also supplied on the servo cables, I'll have parallel ground cables going out to the nacelles, and that is bad design. Both of the arms are tilting back and forth, and also that I mounted the servos in the same direction, so the distance from center of the nacelle for the arm is the same, because that way I don't have to invert one of the channels. I can use just a Y harness for both flap servos. By moving the stick, I then have one of the tilt servos moving, and back and forth I have the other tilt servos moving. So of course this is just for testing purposes, but it's illustrating that the methodology works. There is some space under the spar. I have 6mm square carbon booms, which are really stiff. Two 6mm square carbon booms, epoxied them to the plywood plate, and then have the motor mounted here. Not really sure if the flanks are necessary. I've epoxied the flanks to the carbons and screwed in the servo, but I've also secured it with zip tie. Then connect the aileron cable up, shove it in, put the carbon spar into the hole, which is the other carbon spar for the center wing with the hole in the middle, and just put it in so it goes tightly in, and the other one. For the fuselage, I took out a fresh sheet of Depron, 80 centimeters wide. I also managed to, I had some lamination film, 100 micron, for what we in Europe call A3 size paper, which means that this is a little more than 42 centimeters long and a little over 30 wide. Alright, okay, and as always, before you start, you should rub things down with denatured alcohol. Denatured alcohol is good for two things, apart from being a good fuel in outdoor stoves. One, it's good to remove from Depron grease and other things that from the manufacturing or from handling. And the other thing is that it pretty much eases up hot glue. If you glue something with hello, where are you? If you glue something with hot glue, you just pour a little or damp it with denatured alcohol a few seconds, and you can peel off hot glue. It's really convenient. Let's see what happens. I'll just iron this down and see, it seems to stick. Yeah. Now it's smooth and glazed as it should be, as opposed to the first one, which is kind of wrinkled and not very nice looking. just as a test, we'll try to peel this off and see if it works. Yeah, you can still peel this off. So what I'll do, yeah, it's stuck pretty well to the surface. Okay, fuselage, and this is just short of 60 centimeters long, 42 wide. So let's do some markings. Okay, I just happen to have a square 6mm carbon bar, so it was easy. But basically, what I marked out was 88, 94mm, 204, and 210. Then 298, 304, and then 6mm in, which is 414. So that would give me 11 centimeter wide top and bottom and 8.8 centimeter high sides. And the last one here, just easy to line the carbon bar along the rim and essentially draw the cut line. What you just cut carefully, and then remove the foam. The motors I intend to use, dual sky motors. On the back they of course have the screw holes that are normally attached to a star like this, so you can attach it to any firewall. But I discovered that I hadn't looked properly enough, that the hole spacing is perfect for actually attaching that way. So okay, so just attach the bracket now, still without any screws. And mind you, do use a blue thread locker on all screws. The ones that remember that we were going to do the tail booms from here. Then I thought out, how on earth am I gonna make this disassemblable? But it found out that electrical piping, 60mm electrical piping, fits the 10mm boom, carbon boom, fits right snugly inside here. Okay, so in order to get this to fit really well against the plywood, I'm going to make a flat surface by just making it a little bit narrower using the table saw. Okay, so maybe I cut it a little bit too much, I don't know. Well, a lot of things have happened since I last recorded anything. I mounted, glued to the veneer strips inside the wing, the bottom skin of the wing. I glued the veneer as you showed earlier. I then put the electrical tubing with epoxy, glued it to the wing and put a cable tie through, drilled hole through the veneer and wrapped it all the way through, so this is really tight against the veneer and epoxied all the way on the underside. Then on the other hand, I just covered these nacelles with a piece of 6mm Depron and taped it over. So now I have the motors mounted as well. It makes the all-up weight for the middle section of the wing about 930 grams, which is heavy, but the wingtips with servo included are only 127 grams, each. So now it's time to start to look at the inverted VTOL. The width between the booms is 50 centimeters. That means that the half point is 25 centimeters, right? That means that if we want the VTOL to be, for instance, at a 90-degree angle, we need to be able to calculate how long does the rudder need to be. And if this is 1 and this is 1, then this becomes square root of 2, and that is about 1.41. So let's take 1.4. If 25 centimeters is 1, then we need to take 1.4 times 25 centimeters. 4 times 25 is 100, so that means that we're about 35 centimeters. Okay, so I happen to have some 3mm Depron left from a previous project. That's about all I have, and dented, so I need to put that close to. These are 6mm Deprons. They are now 35 centimeters by 15 centimeters. I thought that the chord is 20 or 19 for the main wing. Maybe it would be a good chord with 13. I made them a little bit bigger. I thought that maybe 6mm is a little bit thick, and just a flat airfoil isn't very good aerodynamically. I want to shape it a little bit. I also need to stiffen it up. Well, I only had 5mm carbon flats, so obviously cutting almost through this one wouldn't be very easy, and make 1mm Depron stick and then 5mm of carbon. So I decided to, why don't I just make this 9mm thick, glue these ones together, put the 5mm carbon in, make it real stiff, and then I have put it against the edge of the table, and I can grind or get 120 grit sandpaper, and then just start grinding. Anyway, it trails off nicely. I've got a dent here, unfortunately, but this is not an exact science, at least the way I do it, and it's starting to look like an airfoil. Okay. So after a little bit of taping, I have two now tail planes ready for further working. I first made the tail surfaces. I then mounted the tail surfaces at 90 degrees and used some 8mm square carbon rod to make sort of a hinge, where I could insert a pin and lock them together. Put a couple of round carbon rods and hot glued them into the wing next to the spar, the 5mm carbon spar that I have running through, so that when I put a rubber band or something else, this is not the best length, I need to have it many times over, I get the tail to hold together, and then just slide it. I just used the rods I have here, made sure they were at the right length, and I beveled the tail surface, beveled 45 degrees, and just hot glued them on here. I will still tape this with the packing tape over, it will be crazy strong. Score through the Depron. Once you've done that, I missed here, it slipped a little bit, doesn't matter so much. Then you just fold it up and try to, you will then break the last of the Depron, and you will have a surface that can move up. And of course, as you know, you fold this over, you bevel this 45 degrees with a sharp knife. Let's hope I made a better job this time. Yeah. Okay. So Okay, so I've just been cutting some carbon. Always wear breathing protection when cutting carbon fiber because it's really bad for your lungs. If there ever was nanotechnology, this is nanotechnology. The fiber dust will settle in your lungs and it will never go away. It's like after cutting loose and taping the tail surfaces, I then mounted the servos just with hot glue, sanding lightly the carbon rod and putting a little square carbon rod as a servo tray just to enforce here the surface that the servo is glued against. And then just taking a cable tie of the stronger kind and wrapping it around, ensuring that the servo doesn't come loose even under stress. Okay, now it's disarmed. Let's see if I can zoom in on the side here. There's a little window where you can access the flight controller is mounted on the side. It's one of the options. Both the elevons moving as well as the motors. The motors probably do move a little bit too much at the moment, but nonetheless. And then the tilt. And flaps. When you want to test it, you hold in and to arm. Now it's armed. So putting some throttle on. I have the motor brake on the rear motor because it's not tilting. If I put some throttle on and then you can see that the wing twists a bit. It's not really ideal. I may need to blast it. Pulling forward with the top. Okay, that's the rear motor cutting out due to overheating. It's only a 30 amp ESC.